Alright, you guys ready to listen to our fire mixtape? We're about to prove to you why light is a particle.
Sir Isaac Newton proposed the corpuscular theory of light. It states that light energy propagates from one point to another in the form of a particle. Light consists of extremely small, weightless, elastic particles called corpuscles. These particles are emitted from a source of light in all directions. They travel in a straight line with constant velocity in the same medium. When these particles enter our eyes, we feel the sensation of light. Rectilinear propagation is used to describe light traveling in straight lines and is easily observed by light rays coming through in clouds. Diffraction. Newton proposed that the wave-like property were collisions between the light particles. Reflection is light from a source arrives on a mirror surface as a stream of particles that will bounce away from a smooth surface. A huge number of these particles are involved in propagating light beams. When the corpuscles touch the mirror surface, they bounce from different positions, reversing their order and producing a reversed image. Refraction. When a beam of light travels through two media having two different refractive indices, the beam undergoes refraction as it changes its direction as it goes through the first medium into the second. Newton proposed the particle theory of light, while Christian Huygens proposed the light theory of a wave.
And with the next verse, we got Alyssa.
Isaac Newton published his theory in 1704. He explains his theory in his book titled Optics after Huygens died. He proposed that light was made up of little masses or particles called corpuscles. And he states that light travels in a straight line at constant velocity except at interfaces, and it travels at extremely high speed. And when corpuscles hit a surface, they all reflect.
And with the next verse, we got B.D. Frank.
When light is a particle, horizontal beam of light is in projectile motion towards Earth, forming a parabola, but we see a straight line because of speed of light. Most commonly observed phenomena with light can be explained by waves, but the photoelectric effect suggested a particle nature for light. Light can't travel through a vacuum. It does not need a medium. How could light reach Earth if it was a wave? If light is a particle, it would have no trouble moving through a vacuum. If light was a wave, why would shadows exist? And why doesn't the light just bend around the barrier? Why is it obstructing like a wave would?
Oh wait, hold on, I forgot something. Alright, now I'm back. Alright, the wave people, they say that light waves are made of white light, and the color spectrum is caused by corruption. But you see, my homie Isaac Newton, he tried to prove that false. He got two prisms showing white light through the first one and split up into show the color spectrum. Then that light went back into the second prism, and then it went back into the first white light. See, I don't know, if it was a wave, it probably wouldn't have done that. And yeah, as I said before, all the waves would need mediums to pass through space. But you see, the light comes from the sun, which goes through space into Earth, but it's a vacuum in space, so waves can't pass through, or particles can. But you see, the wave people, they think that light passes through space through an imaginary medium called ether. Dude, that's ridiculous.
I don't know if I'm going to be able to top off that last verse from my boy, but my name's Jay, and we're about to shut these wave people down. So, although light has interference, it does not have destructive interference. And when light shines on metal, it creates a photoelectronic effect. When the light hits the metal, it emits electrons. According to the classic electromagnetic theory, this effect can be attributed to the transfer of energy from light to an electron in the metal. Electromagnetic radiation can travel through space, but it's made up of tiny photon particles that can mass make it possible for it to go through a vacuum. So, you wave people, you don't know what you're talking about. Wave people, I swear.